Hey everyone, so we did an example today where we converted the complex number z equals square root of 3 minus I to the polar form 2 times e to the minus I pi over 6. And I wanted to just talk a little bit about how you would plot this in MATLAB. So here's MATLAB, and let's say you had z equals 2 times exp, so remember this is e to the, and you put the power inside the parentheses. So minus I times pi over 6. MATLAB will recognize I by itself as the imaginary number I. I usually put a 1i just to be super clear that I'm not using a variable, or if I accidentally define a variable to be called I don't mess anything up with complex numbers. So there's our complex number. Notice that we have square root of 3 here and negative 1i here, so MATLAB automatically converts this into this form. But if I wanted to plot this in the complex plane using MATLAB, I need to plot the real part on the x-axis and the imaginary part on the y-axis. So what I'm going to do is set x equal to the real part of z. The MATLAB command for that is real parentheses z. So notice I just have that number now. And I set y equal to the imaginary part of z. So imag, or imag, is the imaginary part of z in MATLAB, and I just get negative 1. So then I would plot x comma y, and I'm going to use a circular marker and a line width of 3. So here's our plot. We have our real axis is showing that we're going a distance of square root of 3, which is about 1.7 something, so it's right here. And our y-axis, we have negative 1. So this is our number z in the complex plane. So I just wanted to show that really briefly. You just set x equal to the real part, y equal to the imaginary part using imag or imag z, and then you plot xy. Okay. So just in case, so that was all, like the main thing I wanted to talk about in this video. But in case you needed a quick refresher, how did we get these this form of the complex number? So we did this by computing r, which is the modulus of z. So say we're given this form of z, square root of 3 minus I. If we wanted to find r, we would do square root of square root 3 squared plus negative 1 squared, or yeah, negative 1 squared. So this is the square root of a squared plus b squared. This will give us square root of 4, which is 2. We also have theta. So theta is arctan of b over a, so negative 1 over square root of 3. And we saw that if we're looking in the complex plane, I'll draw this line a little bit straighter. Okay, so here's the real and imaginary axes. The angle that we want to take, so remember that the angle that will produce arctan is negative 1 over root 3 might be along this line, and we just need to make sure that we're in the correct quadrant. So root 3 minus I is in this quadrant, so we want to take the angle that puts us here. And it turns out that that angle, let me erase this really quick because it's not super accurate. Okay. So this angle, it's going to be more like that, ends up being minus pi over 6. And remember, we don't want to take, we don't want to do that and take 11 pi over 6. That's not what we want to do, because we're interested in the principal value of the argument. Principal value of the argument. And that just means that whenever you pick theta, you want to make sure that it's between minus pi and pi. So 11 pi over 6 is not in that range, so we want to make sure we're picking a theta value that is. And minus pi over 6 is in that range. And then r is 2, meaning that z is along this ray that extends from the origin, and we go a distance of 2 along that ray. So when we plot z, we just plot the point there. We don't plot it as a vector, so plot as a point, not a vector. So that was a brief summary of what we talked about in class, but I mostly wanted to show you how to plot things in MATLAB. So again, MATLAB plot. So the way to do this, once you have z defined, you set x equal to the real part of z, y equal to the imaginary part of z, and then you plot x, y, and whatever marker you want to use. Okay, so I hope that clears things up, and if you have any further questions, please let me know.